I am live. Let me just ensure that I have audio. This I don't need. Playback. Yep, that should work. So I have audio. Long time no see. Yeah, I've been gone for 3 months. This is simply because I've been in another country for 3 months and didn't have any lab. And as you probably can see from the top here, I removed everything from my previous lab, so now I'm starting to build up, but I have a lot of things in boxes. Still, I wanted to do a stream because it's a long time since I've did a stream and I wanted to do one. And in this one, I actually will tear down 2 things. So these are the 2 things. We have a kettle, so we have a scale, digital scale, and a kettle. And my purpose is I want to build some kind of cooking machine, which is based on boiling water, because most of the things you can do in water could be rice, it could be noodles, it could be pasta, it could be eggs or things like that. For that you need often water, so we can use water, and to have some kind of precision how long to cook and so on, you can also use a scale, so you know how much water is inside, how long you need to cook, and then you can have recipes. And because yeah, just for fun, I want to build one to see if it works, because yeah, it's like a cooking machine. I'm sure it also exists. I want to build my own one. So I got a scale. This is to measure how much water or how many ingredients there are, so the computer knows how long to cook. And then we have a kettle. And the kettle, what was important is that I could control the power, and that the power control is not on the kettle itself, but on the base, because the kettle should be removable easily and the computer will be a bit heavier, so it should be something around the base. So I just wanted a kettle where you can set the temperature, because if you can set the temperature, it has a temperature control, and very often when they have temperature control, they also have power control in the base. So that's what we will tear down. So let's start with this one, and I want to interface it. Yeah, so you could use normal scales, strain gauges, and then just measure things, but I wanted to see with a scale if it's easier. So this one is up to 10 kilograms. I bought the first one digital scale I found for the smallest price. I think I paid 10 euros for it. That's the name. I don't think there's, it's a no name, made in China. Oh, Pronto Digital, maybe that's the name. We have the instructions, electric kitchen, nothing with Pronto, instruction manual with Chinese and English, patent pending, and that's it. There's, here, turn off, prompt, yeah, nothing that interesting. I hope, so this is the device. I haven't used it yet, so I opened it once just to make a picture, but I haven't used it at all, so let's try if it works. I think it should be aluminum, or like brushed aluminum. I think this is just a protection sheet. And how it basically works, so let's let's get the batteries. This is trash. You see how fresh it is? I've never even opened the battery. I just received it yesterday. So does it work before we tear it down? On. Yeah, it works. The screen is barely readable. Yeah, it is readable, and it's inverted. I don't like inverted screens. I won't use it too often, although maybe to put the things inside. I should have put a bit more attention, but inverted screens are hard to use. And then up to 10 kilograms, yeah, overload. Nothing fancy. And how the scale works is that you simply have some kind of weights, pressures right here, and then it just measures with half bridge or full bridge, weight on bridge, I think it's called. you can measure the strain on metal bending. So let's open it up and see what is inside. Let's have good habits and put the thing in small boxes. Up, up. Bottom case. Bottom case. Okay. And now we can put the screws here. Now we know that they all belong to the bottom case. So I fear that this is highly integrated and there's just a chip on board directly on the put of epoxy, and then I don't have any access at all. There are two solutions to that. That would be kind of not the worst case, but that would be a bad case. But we'll see. Maybe there's a digital interface. I didn't even test if it's accurate, the calibration. I hope it is. I hope they did some calibration in the beginning, and there's probably a button sequence to calibrate with 5 kilograms. Up. So it opens easily. Okay, here we can see we have the strain gauges all the time with 3 wires. So this is half. Oh, 3 wires. No, that's fine. 3 wires is fine. And when you press it, you just deform the thing. So the resistance on one side will increase, but on the other side it decreases. And there are chips. So let's see this device, which does everything, but probably it's integrated all in one device. So this is PCB, and it's single-sided. It's single-sided board, fennel paper board. So it's cut down to a price. But we will see if there's a debug interface or something like that. Can I remove this? Yes. One. And else I'll just take, and this is probably what I'll do, I'll just take these feet and the case assembly and put my own sensor. And I think you can use something like HMXX711. We'll see that afterwards. So let's see. Oh, okay. So it even presses against the LCD. Up is the second side. Up. Yep. There's the zebra strip. And we have a couple of test pads actually, but nothing which is interesting. Yep. So, you see, this is what I feared, is that this is a chip on board directly under this epoxy, and it does everything. It has the ADC, which is high precision, probably something around 24 bits, really slow but still precise for measuring the weight. And then it has an integrated LCD driver in here, and that's actually it. So here's the voltage, 3 volt, ground, VCC. I don't know what this is. V. Here is a test pad. So you have test pads for the LEDs. This is a test pad for maybe internal voltage. I don't know. And then you have test pads for all the probes. So, and then this is, oh, is this also an output? Or is it maybe how they test it? Because here, for this button, there is no test pad. goes directly somewhere. Don't know why. Where? Where does it go? It goes here, but it's a single-sided board. Here, it goes all around here. It's this tab pad PT20, and this is PT21. Okay, so you have the two buttons here. This is for flying probes or for needles, or flying probes both the way. So you can test the things. Here we have 1, 2, 3. What is this? This is the infrared LED. Here, I don't know what this one is. This V. Would it output some kind of digital signal? That could be nice, because if it outputs some digital signal and we have directly a readout, which would be interesting. And then we can still, for example, for switching on and setting the tar, we can use the test points here, or we can just solder on the pads. So let's have a look. The oscilloscope. I didn't bring out the oscilloscope. That will be. So here's my oscilloscope. You see that it is protected. Problem with the oscilloscope is I don't. Oh wow, there's kind of glue on top of it. Yeah, I'll have to get rid of it at some point. I have no power for the oscilloscope. I don't have all the cables yet, and I didn't connect it to the. Although I could connect it, so you can see what I'm doing. This is my first oscilloscope. It's still working. Now I would have complete different requirements, but at that time it worked good enough. So let's take the power from the. Is it long enough? Or is it on this side? It's on this side. It's not long enough. I wanted to take the power from the soldering station. That won't happen. Let's take the power from. Can I? Yeah. Let's take the power from the power supply. No, I can't. It's not the same thing. Okay. I need to find a power cord. Let's take this one. I don't know in which box they are. So let me check if the audio still works. Yeah, it works. This is still working. Yeah. So here we have a cord. I'm not even sure I can show you what I'm doing. I could show you this way. No. I'll try it first on my own to see if there's a signal. If there's a signal, I'll show you. The signal. This is trash. Up. Does this oscilloscope still work? I need to switch on the power. Power is on. Oscilloscope starts. So it works. I need to find the probes for the oscilloscope. I think in this box. 1, 2. Yep, I found the probes. That's only something. This is trash. So channel 1 up, channel 2 up, and trigger input. We want the trigger inputs here. These are metal. Let's put it this way for now. If it works, I will connect it to the network and then you can see what's happening. So we want an auto trigger, or maybe let's try it. Maybe the cable is long enough. Is it? Might be. Not sure if it is. And this is broken. Okay, I fixed the DMM. That's too short. Damn it. is it? Cause can I make it longer? Yep, I can. That's not an ideal setup, but it should work. For now, let's connect the network. The useful part in the network is it is isolated, LAN connected. Does the script work? Oscilloscope capture. Capturing and display. Does it work? Oscilloscope seems to work. Yeah. Let's put the oscilloscope currently here. We don't use the DMM. And let's have a look at the thing. Up. Up. So we won't see anything. Does it beep? We also don't know. Minus is here. 200 milliseconds too long. I don't care. So here voltage. Maybe it could be a digital signal. This is, let's put it, no, this way. Up. 1 volt. So we have 2.8 volts. Yep, because we have 2 batteries. That's fine. On. Okay, switch is on. The LCD is on. There's nothing, there's no data. We don't use channel 2. Switch it off. And what if I press on it? On one of the things. No. So here, this is VDD. 3 volts. Yep. This is ground. Not sure what this is. It's probably one of the signals. Yes, it's one of the feeds. Yeah, I hope that this one would be something, but it doesn't seem to be. Let's try again. Yep, no output, nothing. But I can probe it while the LCD is not on. So we can test it. I could probe it by soldering a cable. But I think there's nothing there. Let's solder a cable. Up. Do you have wires somewhere? I think they're in this box. Something like that. Up. Do you have a wire stripper? No, I don't have a wire stripper. Let's use this. Okay. Some solder. And I will put I should put the sponge for soldering. Okay, sponge is wet. Soldering iron is almost ready. Let's remove the power while soldering, although it shouldn't be any problem. What the hell? Okay. So V like voltage or what's up? Okay, we have a wire. Well, the other ones are not interesting. Although they could be out. No, they couldn't be outputs and inputs at the same time. Would be a bad practice. So let's put this back in. Up there are some studs here. Clips should be able to clip at this point. Yeah, one clip. And clip. I could have made a ground signal also. Can I still? I can still solder one here. With the same color? No. I think I have. So let's cut this. I should have another. Yeah, I have black also. Up. Black wire. Oh, oscilloscope is taking a bit too much space. Up. Okay, stripping when you have no wire stripper. There's enough solder here. Bit more solder to have more contacts. Okay, it's crappy solder. Should still work. Okay. So ground up, strip everything up. So we have ground, we have V, and then we can test if V does something. Okay. Ground. V. V is at 0. We don't have any power. Let's put some power. Okay. V is at 3.3 volts. Normally, this should work again. So on. Okay, it needs more pressure. So I do need to put the screws on. It has a bit more pressure. This needs to be charged. So if one is enough, actually I could put all of them back. Up. And there were only, why is there a fourth one here? It's not important because it's not, did I lose one? No, there don't seem to have been any. Casting. Okay, so let's try again. On. The display works completely. It starts, and then if we press, yeah, the voltage doesn't change at all. You can see in the oscilloscope that nothing changes. So we can't reuse this. There is no output. So there could be other ways to do it. You could grab actually the LCD output and just reverse which segments are on. This could be one trick, and I did it for a sound meter. And then you just probe the scan points, and then you figure out again, you reverse back which segments are on. I don't think I will do this. I'll just reuse this tiny feet probably, and the case. Yeah. And then I will use modules which can read from it, and I need to calibrate myself, but yeah, calibration is not that hard. Let me find if I have the data sheet for that. Data, I think I have a data sheet for its sensor, transistor, no, sensor, weights, yeah, weight, this one. So I'll switch to full screen. Exactly. So this, the HX170, it's you find plenty of modules using that. Can I use this? Because I have plenty of modules, can I use this? So here it has only 2 channels. Let's have here 24-bit, okay. ADC for weight scales, 24 bits. The input multiplexer select either channel A or B, differential inputs. So I would have to add all of them. I would need 2 of these chips. Select here, load cell. So can you combine? See, there are 3 wires, but no, 1, 2, 3, and then ground. And we have only 3 wires on these things coming out every time. I don't know how they work. Is there a diagram for the case where you don't put okay, this is just code. I already programmed once, read them once, I already used them once, but I had really the right connection. So this is for weight scale, differential input, program power, full scale differential input. Channel B has fixed gain, and channel A has changeable gain, clock input flexible. I don't care. Yeah, so I don't know. This is a load cell. But a load cell with 3 wires, 4 wires. We have only 3 wires. I think it's not called a Wheatstone bridge, but something else. Let's have a look. Load cell configurations. Yes, for example, here there are only 3 wires. 1, 2, 3. Here there are 4 wires. Is this thing 3 wires or 4 wires? I'm looking right. They have only 3 wires. 1, 2, 3. Wheatstone bridge. So they're only resistance all the time, and they're ground. So actually they are only one resistance at the time. So I can put all of the 4 together and create the Wheatstone bridge. Is it this how it works? Let's have other pictures. Here. This is probably how we will use it. How to use load cells exactly. exactly. So these are the cells, these are the pads. Yeah, they are different cells. This is using a load cell. Okay, here. Exactly. I've used things like that where you have already 4 wires. But in this case, we have 4 of these. And how? Here. 4 half cells. Okay, they're called half cells. This way. So you connect the ground together. Okay. Okay, so this is what we'll do. I'll just not use the... Well, I can still... Can I still use it at the same time? No, I don't think so. I'll just get rid of this. I will use this plastic just for the frame, because the frame is there, and I will put myself a Wheatstone bridge, the HX71. Then I need to calibrate it with probably 0, 1 kilo, and 5 kilograms, maybe 10 kilograms. And we will do it this way. And I can even calibrate it with the same cell, but I have another one. At least I have the frame, and that's good enough. So this is the third thing. Up. So I will need a Wheatstone bridge. This is the first project. This is complete. Let's put it back together completely before I close it. I can leave the wires inside. Let's close it completely. Put that in the box. Up. But I wanted to frame. And this is the most important part. The frame works. This is worth the 10. And the cells. This is good because now I have the cells. This camera is far too high. Up. Cells inside here. We won't use this anymore, so I can cut it. Don't cut the other things. Up. Up. I don't need the soldering iron anymore for now. I don't need this. Let's clean up so we can put the next one on the bench, which is probably more interesting because I don't know how it is inside. I have some clues, but I don't know how it is inside. This one I probably, this is exactly what I expected. Up. 1, 2, 3. Up. Let's close this. Let's test if it still works. So if we press long, it should go off. Yeah. On. Still works. That's fine. So I will just use the base. I will just use the case and stick the second device on it. So let's get to the second device. Let's put this away. This needs to be charged. We don't need the oscilloscope anymore. Oh, you don't see what I'm doing. Bench. Let me switch back to the bench. Up, bench. You don't need the oscilloscope anymore. Up. We'll probably need it afterwards, but we'll see that afterwards. Oh yes, this goes here. that device is finished. Let's get the next one, the kettle, which is probably a bit more interesting. So, I got this for 50 euros. This is Keg 8041GS. We also no name, made in China, Edelstahl Wasserkocher. Let's manual. Who needs a manual if we tear everything apart? And the kettle itself. That's some unboxing. So this is the kettle, maximum 1.7, and I wanted one with the grid so I can put things inside. For example, I could put the pasta, just one portion of pasta, or eggs, or things like that. It is a bit small, but it's also a fun project. Yeah, you can put one. I think an egg would hold and then would finish. I'm not sure if it's easy to clean. It's meant for tea. Definitely it's meant for tea, maybe coffee, I don't know, don't drink coffee. But we'll use it for plenty of other things. Maybe enough pasta can go inside so it also works. We'll see. But the most important part was the base. And how does it measure the temperature? It has metal rings. It has plenty of rings actually. In the center there is one, so 1, 2, 3, 4, 5. 5 connections. Maybe there. We'll have a look at inside afterwards. Let's try it out if it works. Up. Up. It did work. Oh, this is crusty. But yeah, what I wanted also is that, yeah, the base, I can still use this. This is, it feels really crappy. I mean, I didn't pay a lot for it. But this feels crappy. Custom temperature, keep warm. Press for 3 seconds to mute. So there's even a buzzer. What if I put the thing on top? Does it detect it? No. Or at least it doesn't say. Okay, it did beep once. What's on with the screen? It just doesn't. Okay. Oh, it's a nice screen. Yeah, you can probably see it. You can change the temperature. This feels so crappy. It's hard to imagine. There's no indent. Formula, delicate. Formula, warm, coffee, boil, black, oolong. So you can put different type of teas. Okay. Does it have a light? I don't. Maybe. Does it have a light? I don't know if it has light. Let's put some water inside. It detects when it's there and when it's not there. So it does measure. Oh, that's nice. You could measure the resistance, but I'm sure they do it another way. Okay. There's a tiny bit less than the minimum. And another thing I wanted to do is, because most of the kettles are really, really loud, and in the morning I hate it. So what I want to do is build a kettle which is silent. This is probably the most important things I wanted to do. So let's go to boil. There's water. Yeah. And start is press for 3 seconds off. This is start. It says 20 degree boiling, and there's no light, is there? No. But and it's not loud. I don't even have to change anything. It's not loud. Here it shows the temperature in real time. This is good. It has a temperature sensor. and this is probably also how it detects that if it's connected or not, by reading temperature sensor. It's probably just an NTC. You start, now it starts getting loud. This is what I want to stop. Let's put this on. It's more than 40 degrees Celsius. I'm not sure what they're measuring. Probably the center, but on the side there, it's already boiling. I can't show you, but yeah, on the side it's already boiling. But it's pretty silent. You probably see it from the here. You see that vapor is coming outside. Stop. So everything is boiling. So this works. Keep warm. What's keep warm? Yeah, warm. You have to be in the modus. 50. Keep warm for 2 hours. Okay. And it complains when you remove it. So let's have a look at what's inside the kettle to see. Probably there's a resistance and there's a temperature sensor. Let me just get rid of the hot water. Let's cool it down. I should have taken one with an LED inside, but I could still put some lights here and show what it does. Up. So yeah, it's cold enough. It even says how warm it is. 52. Yeah, it's good enough to touch. So this is the bottom. Let's have a look at what is inside. So we know that there is at least, so there's one heating element and there's at least one temperature sensor. It's the wrong screwdriver. This one is not a lot better. It's a tiny bit better. Hop. Or is there something beneath the sticker? No, I don't think so. Why can't I? Oh, let's try one opening tool like that. Hop. That's too fragile. Is it glued on? I think so. Okay. This is just a cover. Ooh. It has a container. Okay. Oop. This black seal on the back. Do I want to break it? Still want to see what's inside. Don't want to break it. Can I remove this thing? Okay, that's one side. Okay, now it clips. Up, up, up. Oh no, this is plastic which is just broke. Yeah, I think it's just remaining. It's not important. Ah, okay, there it is. There's the last screw. These are on the bottom, not in case. Up. Okay, now I can, yep, this is the last screw. Up. Like PCB, it's not really PCB, but let's put it this way. Now I should be able to remove the case. Yes, I can. And we can see what is inside. Multimeter is here. Let me have the multimeter reading for you. Does this work? Connecting, yeah. This should work. We go in continuity mode. Let's get rid of this. And we can try to probe what everything is. So here on the outside we have the heating resistor. This here, there is a thermal protection. So there is at least one thermal protection. So power comes in here, goes through thermal protection, then through the heating element, which is on the side, and then back here. And we have two connections for, this is a temperature sensor. This is probably just a 10 kilo ohm MTC. I don't think, yep. Let's measure what does what, and let's write it down. Do I have some piece of paper? Paper, pen, which I should sharpen. Do I have a knife to sharpen it? I don't have my sharpening tool. Okay, so this works. This is live, red. This is the second. So this is center, and then we will call, so ring. This is C, center. I think center is connected to nothing. Ah, maybe just to the metal case. This, no. It's not, is it not? No, it's not earth. Is it? No, nothing is connected. Ah, the outside is connected. Okay, so there is earth. Okay, someone is there. Hallo? Hallo? Ah, moon. Up. And the DMM, it's not enabled, so you don't see anything. DMM. Okay. Let's see how long I can do the stream. There's visitor coming. Let me just greet the visitor and say that I'm streaming. So I'm back, the audio is here, and let's have it done. So now you should even see on the DMM, I think I need to change it so the the question mark is actually meaning that this is in continuity mode. So it is Earth, so the side, the last ring is, so this is ring 0, 1, 2, 3, 4. Ring 4 is chassis, and the chassis is probably Earth. Then we have ring 3, it's this one. Ring 3 is temperature 1, temperature probe. Then we have ring 2, it's probably the second. Oh no, it's not. Huh. Didn't expect that. It's neutral. Ring 2 is neutral. Ring 1 is probably now the temperature. Let's check. No. Ring 1 is live. Ring 1 is live, and then the midpoint is probably then the temperature. Yep. And ring 0 is T2, the temperature. And now we will check just the up resistance between the two, and if it's around 10K, then we know it's a 10K PDC. It is not. It is completely. Do they use a thermocouple? No, okay. It is a 10K PDC. We are at 58K, probably because it's at 50 degrees. Does it change that much? But it is increasing as the temperature is going down. So I'm not sure if it's a 10K PTC, but it is actually a negative temperature and PTC. Yeah, I think it's PTC, positive temperature coefficient. Just the resistance which changes with temperature, and you can see the resistance rising while it is cooling. So it is an NTC. I don't know. These are the connections. This is fine. Let me take a picture before I close it. Again, no memory card. The memory card is here. I could reuse the stream, but it's easier to just take a picture right now. And now we will have a look at the base. This is probably also just a ship-on blob with the driver. I'll probably put my own screen on there. So let's close this first. We know that this works. It's mighty fine, and it's just an NTC. Up. Our rubber gasket go on top. Here we are in the middle. Up. That's the screw which was on the side. And then I will just have a programmable water boiler. But I'm impressed how silent it is. Maybe it is less silent when you put more water. I'll still add some features. With the PTC, I could even trick and then add an LED. I won't do it. So this is one screw. Now the 3 big ones. Up. And the build quality is not that bad till now. It's actually, now I know. It's actually a good idea to put the brown on the outside, and it makes sense when I'll show you the base. Okay, so you see the base. The contact here are probably, I'm not sure if they're live or not yet, but this can't be live. So this is the chassis. This is probably earth. Let's put the kettle to the side. We don't need this, we don't need this. Let's have a look at this. There's probably no power. I hope there's no power when there's no kettle. How does it detect it? Just by measuring if there's the NTC inside. Probably if we put a resistance, it will think that there is some kettle. We won't do it now. We don't, the purpose is not to hack it currently. So we can actually test it. We know that it is ring. So let's go to AC, voltage measurements, voltage, AC, and you are still seeing, yeah. So between ring 0, so this is ring 0, and ring 2, this is ring 2. 27 volts. Why does it put power? Maybe this relay is not completely on. Why does it put power? Does it detect it this way when there is a tiny bit of power going through? It's a bit surprising. Yeah, there's 30 volts. That's weird. Let's open it up and let's see how it is. Again, I just expect it to be a chip on board, and on which handles all the buttons and so on. And here there's just something like a SCR or thyristor, is it how it's called? Thing to manage AC. Oh, where are the screws beneath these things? Yep. 1, 2, 3, 4. Let's open it up. And again, I'll probably just reuse the thyristor, and that's it. We'll see what's inside. Up, tech. So these are self-tapping screws, not into metal, but I mean, for this price, I'm even impressed they are screws. It's not just clicked all in place. Yep, yeah, here we have the e-waste logo because there's electronics inside. Let's get the last screw. Up. Up. Let's switch off the oscilloscope because it makes too much noise. Oscilloscope, where is the switch? Yeah. And no, I didn't break it. Okay. That should be able to open. Yeah. There is still a clip somewhere. I can feel it. There. It did click. Okay, there's a tiny bit more than I expected. Here. The electronics are here. So So out there. It's that's a good point. Very good point. This is conformally coated. Probably because it's dealing with water, vapors, and it could spill, so the conformally coating would protect it. Very good. Yeah. Very good. The LCD is soldered on it. This is probably the LCD controller, and this is then the main processor. Let's find out. These screws, are they holding? Can I remove them? No, they're holding. And here is what we expected. Ground, live, neutral, and the two probes. This is the temperature sensor. Here is also a temperature sensor. R25. Maybe not. No, it doesn't have to. It's a single board. They use the resistance, the resistor just to. Here doesn't make sense. No, there's something with that. There's no trace going under, so it's not like a resistance used to make bridges. For example, here they are having a trace under the diode, but it's a huge resistor. Probably should. This is a temperature thing just to measure the temperature of the board. Let's see. PCB. Bottom case. Oh, damn it. It's less impressive than I thought. I wanted actually to control how fast it rises and not. So I wanted to use an SCR. Here we don't have that. This is just a relay. So it switches on, and then if it reaches temperature, it switches off. Can also use relays. But we cannot cycle it very often. Here we have two LEDs. Here we have the rotary encoder. Here just buttons and next to LEDs, so nothing that impressive. This is the power input, and here we have protection capacitor, the spades. This is PTC, so yeah, it is a PTC. The buzzer, just some. I don't think, no. This is probably some reading resistor. And this is probably the voltage regulator. APQ03. Because I don't see any voltage regulator on this side. I see two ICs. This is an VK1072C. Very probably the LCD driver because it's connected directly to the LCD. And yep. This is an FMD ferromite. They do microcontrollers. FT61F143. This is the microcontroller. So, can I reuse that? I will reuse the base. Maybe the connection, the buzzer, the LEDs. I'm not sure. I wanted really an SCR. I do have SCRs. They're just big to handle so much current, and this is just a relay, 10 amp 250 volts, nothing fancy. Oh, this is an inductor, maybe for the voltage input. There's no coil, so I'm not sure how. There's a coil, but there's a coil, but there's no transformer. L1, L2, there are two coils. I don't know what kind of inputs this is, but I'll probably design my own board with a screen. Not sure if I will do it with a relay. I really wanted to control how much power goes, so I can ramp up and slow it down as I want it. But that's the teardown of this device, and I'm impressed by the build quality for this price. I paid €50 for it. It works out. L, this is L, neutral, out L. Why out L? Wait, there's something I've missed here. No, this is the out. Okay, so there's the input, which is L, goes through the relay, and then it goes to output. And here the neutral goes directly to it. Yep. Nothing fancy, but it's still well made, still single-sided. Here the couple of resistor and diodes. The diode, so this is, yeah, oh, it's here. This is a transistor to switch on and off the relay, and this is probably the flyback diode, because you don't want the microcontroller to switch on directly the coils. It makes too many spikes. It's not a good thing to do. And also this is 6 volts, so probably this is running at 6 volts. Could measure it, but who needs it? This is the input. I will just reuse, no, I'll just put my own LCD here, my own microcontroller, and redesign this board. I'll just use the form factor because we have the buttons. I'll just reuse this thing. The inputs, I'm not sure. I don't want to touch it while it's live, but there is, here we could measure. There should be something around 5 volts, but not a lot of current. Although enough to switch on this. So I could reuse the power input from that and just put my own microcontroller. But that's it. That's the teardown of this kettle, and we will modify it heavily. I don't want to use a relay. I will use a really SCR where I can change the how much current goes inside. And I need a large SCR, but I have a large SCR to handle 10 amps. I'm not sure if this handles 10 amps, but still, I have large enough SCR. Even if it's on the side, it's not too much of an issue. Is there enough space in here? Maybe my microcontroller will be small enough that I can fit it somewhere in here. No, it's too large. Could still have it on the side. Not too much of an issue. But yeah, I will not use a relay. I'll use an SCR. Then I can control how fast it heats up. And we can cook things with that slowly, like rice. You want to cook it very slowly. And you could actually, because it's a huge mass, you could switch on and off the relay, but the relay wouldn't live that long. It's not ideal. And I have an SCR. So that's it. We have the teardown, and I'll do the projects for the other things afterwards. We'll probably have some live streams where I show you how the progress of my cooking machine. But that's it for now. And yeah, it's a short stream, but it's just a teardown for a couple of things, and you see that my lab is not completely ready. So yeah, enjoy the rest of the day. Bye bye.